Understanding visual programming. Artificial intelligence already changed everything. Books, art, music. Your next favorite song will be something you ask your AI to compose for you. And the next breakthrough in medicine, perhaps an anti-aging treatment, will not come from a pharmaceutical company, but an AI company. I am saying that your favorite source of news, memes, stupid jokes, and photos will be the AI that runs on your desktop at home. And while you are correct in thinking that AI is too primitive for all this, you are wrong about AI. You need to learn to think in multiple dimensions. Because two AI talking to each other about who is more correct can teach the third AI to build the fourth one. I would say, welcome to the future. But the future went right past us. This is a new era. The next breakthroughs are not coming in a decade. They are going to come tomorrow, and there will be more day after tomorrow. The future flew by us so fast. We are all currently outdated. That is the silence you are hearing. Preface. You were about to hear about ports and boxes. This will be very, very boring. But throughout this dry explanation, I want you to secretly remember the following. Every smartphone and desktop app, even the Linux program, or even the phone itself is a box. Your camera app is a box with an input port that is an actual camera lens and an output port that are the photos you take. The reason why this is important is because visual programming is about to become the new standard user interface. It will be how you interface with databases, how you save your photos, export your texts, back up your files, and yes, integrate and reprogram your AI. Visual programming languages will be the user interface behind the first powerful, strong AI. It is how we will be able to understand it and update it as needed. Visual programming is actually very easily explained. It is the pneumatic tube or capsule pipeline that we see in movies sometime. You put a message or an envelope in a capsule, jam it up the tube, and the tube is sent on its way by means of compressed air. These systems require humans to open the capsule, read the message, and send it down some other tube to another department. And in the visual programming languages, the humans are of course replaced by the boxes. Boxes represent actions or functions or programs or API calls. But I will use the generic term box in this explanation. To route a message based on its content, you would use an if box or a case box or a filter out box. To understand the system at greater depth, know that every box has ports. In fact, a box is just a convenient grouping of ports. It is possible to make a visual programming language where it is all just ports connected by lines. But attaching ports to color-coded boxes that have a caption and a useful icon, maybe even a little minimalist bar chart on the bottom showing some statistics about the data flowing through it, makes things more readable, more human-friendly. If all you have is ports connected by lines, things will get confusing really quickly. A box has input ports and output ports. Inputs configure the box and send in data. In object-oriented programming, inputs are called properties. In more traditional programming, they can be thought of as variables. Output is where the function of the box is evaluated, where the whole box does its thing. In object-oriented programming, those would be the methods or functions that in this particular context consume properties. So the output port would just be the output method that reads some of the input ports or input variables. Object-oriented programming serves as the perfect framework and fits very well beneath a visual programming language. Just remember that when you are creating boxes, you shouldn't create the boxes that the user sees on the screen, as those are instances of all the possible boxes that the user can drag on their canvas. What you are actually programming is a library of box types that the user can drop on their canvas. Moreover, input as a property is an array, as it would contain links. Links are created when an output of another more distant box is connected to the one that you are at. When the program is ran, the object would ask all the linked outputs to bring in all the data. It would execute the functions represented by those links, and then present the results in its output function. This is just a couple of lines of recursive code. It's not hard to program at all. Basically, output ports are mini programs that consume information from the input ports. To give an example, if and else are two output ports that route information on a condition input port. A condition can be past due equals true, and there would be a condition box that the user would need to plug in here. All the data coming in on the primary input port would be ran through the condition and then simply sent out via the condition true or condition false ports. Your favorite spreadsheet program is actually a visual programming language reduced to bare bones. It is actually like a sad graveyard of once a brilliant idea. There are no boxes here that group ports together, but every cell is a kind of a port, and the way you connect these ports together is by referencing them in a formula. For example, a cell C1 with the formula sum A1 B1 represent three boxes in a visual programming language. A1 and B1 are just number boxes that simply send out the number that has been put in them through the output port. In a more complex program, rather than number boxes, they would represent some other complex program that outputs a standard number. And C1 is either a sum box or an operation box that has functions like sum and average. Here, to reference A1 and B1, you must connect them to the input port of the sum box. The best way to learn visual programming today is to install Node-RED or set off to learn Blender and geometry nodes. But I would like to encourage you to actually learn JavaScript and explore the realm of visual programming inside out by creating a small SVG-based OOP-backed VPL, preferably with fantasy user interface elements so that you practice the GUI magic. And should you need a more compelling reason, create a visual programming language that will help you build the next generation of the visual programming languages. Because visual programming languages will be in high demand to control AI and other high complexity that AI will now allow for, you may also wish to consider building a small startup around your visual programming language offerings. A useful tool that does the job well is often quite priceless.